The edge of the Milky Way galaxy is defined by the outermost distribution of stars, gas, and dark matter that's still gravitationally bound to the galactic disk. It lies approximately 100,000 light-years from the galactic center along the plane of rotation. Beyond this boundary, the density of stars drops sharply, marking the transition to intergalactic space. The stellar halo extends farther than the visible disk, reaching up to 200,000 light-years in some directions. Dark matter forms an invisible spherical envelope around the galaxy, extending far beyond the visible edge. The Sagittarius dwarf spheroidal galaxy is being torn apart and absorbed at the Milky Way's outer rim. The Canis Major overdensity is a stream of stars once part of a dwarf galaxy now merging with our galaxy's edge. The Milky Way's edge contains no spiral arms; those structures end well within the central 60,000 light-years. Globular clusters like M55 and NGC 7006 orbit far beyond the galactic disk, tracing the outer gravitational influence. The galactic thick disk, a population of older stars, thins out gradually and merges into the halo near the edge. Hydrogen gas clouds in the outer regions are extremely diffuse, with densities under 0.1 atoms per cubic centimeter. Cosmic rays originating from the galactic edge travel farther before colliding with interstellar material. The Magellanic Clouds orbit the Milky Way but lie outside its official gravitational boundary. The edge lacks significant star formation; new stars rarely form beyond 50,000 light-years from the center. Astronomers use pulsars in the outer halo to measure the galaxy's rotation curve at extreme distances. Radio telescopes detect faint 21 cm emissions from neutral hydrogen only in the outer reaches of the galaxy. The Milky Way's edge is not a sharp line; it's a fuzzy, uneven transition zone shaped by tidal forces. The Gaia spacecraft has mapped over 1.8 billion stars, revealing gaps and clumps in the outer stellar distribution. Some stars at the edge move faster than expected, suggesting past mergers with other galaxies. The outer region contains ancient population II stars, over 12 billion years old, among the galaxy's first. The galactic wind, a stream of hot gas, escapes upward from the disk but is contained by dark matter gravity. The Virgo supercluster's gravity subtly distorts the shape of the Milky Way's outer halo. The Oort cloud, while not part of the galactic edge, begins at 0.1 light-year and extends beyond the solar system's influence. No known exoplanets have been detected beyond 50,000 light-years from the galactic center. The edge is illuminated faintly by the integrated light of millions of distant, dim red dwarfs. Molecular clouds necessary for star birth are nearly absent past the Perseus arm. Gamma-ray bursts from distant galaxies occasionally pass through the Milky Way's edge without interaction. The local void, a vast empty region, lies just beyond the Milky Way's gravitational reach. The Sun orbits at 27,000 light-years, a position well within the inner two-thirds of the galaxy. The leading edge of the Milky Way moves toward the constellation Hercules at 600 km per second relative to the cosmic microwave background. The trailing edge is stretched by tidal forces from the Andromeda galaxy's gravitational pull. The galactic disk warps slightly at its outer rim due to interactions with satellite galaxies. Neutrinos from supernovae in the outer halo arrive at Earth with minimal scattering due to low matter density. Star clusters in the outskirts are often disrupted by tidal shear from the galaxy's differential rotation. Dust extinction is negligible beyond the outer spiral arms, allowing clearer views of extragalactic objects. The Milky Way's edge emits less infrared radiation than its core, due to lower star and dust density. Astronomical surveys find that the stellar density at the edge is less than 1/10 of the solar neighborhood. High-velocity stars like S5 HVS1 were ejected from the galactic center and now drift beyond the edge. The escape velocity at the outer edge is roughly 500 km per second, lower than near the galactic center. The magnetic field of the Milky Way weakens exponentially beyond 40,000 light-years from the core. Cosmic rays from the edge have lower energies than those generated in the central bulge. The edge contains no active galactic nucleus or supermassive black hole influence. Only 5% of the Milky Way's total mass resides beyond 80,000 light-years from the center. The outer disk rotates more slowly than predicted by visible mass alone, revealing dark matter's presence. The Hi layer of neutral hydrogen extends further than the molecular gas layer, defining the galactic boundary. The Sculptor dwarf galaxy is a satellite currently passing near the Milky Way's outer fringe. The outer arm, also called the Perseus arm extension, is the last recognizable spiral structure. No supernova remnants have been confirmed beyond 60,000 light-years from the galactic center. The Fermi bubbles, energetic structures above the galactic plane, do not extend to the edge. The globular cluster Palomar 14 orbits at over 180,000 light-years, the farthest known object bound to us. Interstellar dust grains at the edge are smaller and more fragmented due to prolonged exposure to cosmic rays. The galactic corona, a hot plasma sphere, envelops the Milky Way and extends beyond its visible edge. The edge is not a barrier, it's a dynamic boundary where the galaxy exchanges material with intergalactic space. Gas clouds from the local group occasionally fall into the Milky Way's outer halo. The stellar velocity dispersion increases at the edge, indicating a transition to a more chaotic orbital environment. The metallicity of stars at the edge averages less than 10% of the Sun's, reflecting early galactic conditions. The Sloan Digital Sky Survey revealed a stellar stream called the Cetus Stream originating from a disrupted dwarf galaxy. Tidal tails from past mergers stretch beyond the visible edge, forming filamentary structures in the halo. Satellite galaxies like the Ursa Minor dwarf exert measurable gravitational tugs on the outer stellar distribution. The Milky Way's edge is not static, it expands slowly as dark matter halos accrete new material. X-ray emissions from the outer halo are faint traces of hot gas heated by ancient supernovae. The edge is where the galaxy's rotational shear overcomes self-gravity, preventing new disk formation. Microlensing events are rare at the edge due to the scarcity of compact objects. The Milky Way's edge defines the limit of its star-forming influence in the local group. At the edge, the gravitational pull of the Milky Way is weaker than that of nearby dwarf galaxies. Stellar orbits in